guys, it's Miss Phoebus, and this is lesson 33, linking factors and zeros in quadratics. And then we're also going to be doing graphing in factored form. So it's like two little mini lessons kind of shoved together into one lesson. All right, on page 141, if you have the notes, you're going to highlight the words that you already know or you think that you know. You can highlight them with a star, you can highlight them with a box, you can highlight them with a highlighter. All right, the words that we're going to be using today are parabola, which that's the name of the U-shaped curve that a quadratic makes, so we can use those words interchangeably, parabola and quadratic. And then factored form is one form a quadratic equation can be written in showing the factors of the function. There I have an example for you where it looks like somebody had factored this quadratic. This is factored form. Now we have three different forms and we will talk about them over the next 3 days. So today is factored form. And then the last thing we're going to talk about is the zero product property, which is the property that states anything multiplied by 0 is 0. We use this property to solve quadratics, and we're going to be solving quadratics later in this unit, but the zero product property is something that's going to come up and is something that we're going to use. All right, so on page 142, these are the learning goals that we're learning for the lesson. So the first part of the lesson is going to use 51 and 52, and then the second part where we're graphing in factor form is going to use skill 46, but we're identifying zeros. They are already going to be factored for us, but we are going to do a little bit of factoring today. And then can you identify when a quadratic is not factorable, when it does not cross or touch the x-axis and therefore has no real zeros? And then I can graph quadratic equations written in factored form. So these are our standards. Factor a quadratic expression to reveal the zeros of the function it defines. Identify zeros of polynomials when suitable factorizations are available and use them to construct a rough graph. And we're actually going to kind of go a little bit more than that. We're going to do a precise graphing of these. And then graph, we're not doing the linear, but we're going to graph quadratic functions to show intercepts. And then maximum and minimum, the vertex, that's going to be tomorrow. So we're on page 144 in the notes. And on page 144, you have a whole bunch of stuff there. We're going to fill in some blanks. You ready? Here we go. Factoring is a very helpful skill to have. It enables us to solve equations and find x-intercepts for functions, quadratics, as well as other polynomials. It is a skill you will use in most other math classes and on the ACT. A zero is the location where a polynomial intersects the x-axis. These are also called zeros because it's where the y value is always equal to 0. A factor is one of the linear expressions of a single variable polynomial. Example, we have x plus 3 and x minus 2. A polynomial can have several factors. So usually 2 factors indicate a quadratic, 3 factors would indicate a cubic, 4 factors would indicate a quartic, and so on. All right, so this is the graph of the polynomial y equals x squared plus 2x minus 8. It's a quadratic. It's got an x squared in it. It crosses the x-axis in 2 locations. Can you see where it crosses the x-axis? It has x-intercepts at -4, 0 and 2, 0. So we would say it has zeros at -4 and 2. Notice that the y parts of the point are 0. So when we call them zeros, we're saying, well, we already know the y value is 0. What is the x value? So let's play around with this idea of factoring and zeros. So what we're going to do is we're going to take the piece that's on the right-hand side of this y equals, this equation, and we're going to look at that and factor it. So if we were going to factor this, we would want to find two numbers that multiply to give us -8. Those same two numbers have to add to give us 2. And so we would be looking at a +4 and a -2. 4 times -2 is -8. 4 plus -2 is 2. X plus 4 and x minus 2. That would be what we would get when we factored. So if we'd like to know the zeros of the polynomial without graphing, all we have to do is make each parenthesis equal 0. And so this is the zero product property. I can take something and make it equal 0, and 0 times any number is 0, and vice versa. I can take any number and make it equal 0, and 0 times some other number is going to give me 0. So the zero product property allows me to solve those equations and figure out the solutions, and really I'm figuring out the x-intercepts, x. So if I was going to solve this x plus 4 equals 0, if I was going to solve for x, I would subtract 4 on both sides, and I would get x equals -4. X minus 2 equals 0, I would add 2 to both sides, x equals 2. And if you notice, you're like, hey, those are just the opposites, right? I see a +4, and my answer is -4. I see a -2, my 0 is +2. Yeah, it's all about opposites, all of it. Okay, so a factor helps us break apart a quadratic or a different polynomial. A 0 is where does that polynomial, where does that graph cross the x-axis? And so they are linked together. So if you know the factors, you can find the zeros. And if you know the zeros, you can find the factors. And we'll talk about that later on. All right, so you are going to be in one of 3 boats when you're dealing with quadratics. You will have 2 zeros, 1 0, or no zeros. And when we say no zeros, we're going to learn to write that we're going to write no real zeros or no real solutions. Now, when we say zeros, we're looking again at those x-intercepts. So here's 1 x-intercept, here's 2 x-intercept. So that's why we have 2 zeros. The 1 0 that's happening here is where it kind of comes down and it kisses the x-axis and leaves. And so this is a repeating 0. And so you'll have something like x equals -2, and oh, x equals -2 because you're in this boat of something like that. And if x plus 2 equals 0, x equals -2, but really remember that when we have that x squared, we really have 2 parentheses that look exactly the same. And so it's like solving those twice. So you have a repeating 0, and that's actually what we call multiplicity, but you don't have to worry about that. That's algebra 2. Over here on the right, we have no zeros. It does not cross this x-axis at all. No zeros. So we would say no real solution. Now, that implies that there is a fake solution. And it's not really a fake solution. It is something that we call imaginary numbers. Okay, the imaginary number system is actually not imaginary. It got a terrible name kind of thrown on it because the people of the time, the guy that created these and figured these out, he was ridiculed and told that that didn't make any sense and that his number system was absurd and all of this stuff. And so actually it was Rene Descartes who titled these imaginary numbers, and the name just kind of stuck. But they are there is a solution, it's just not in a 2-dimensional plane. It's outside that 2-dimensional plane. So we have 3 situations that we can be in. And usually in this last one, not always, but our unfactorables are usually in here. Okay? Sometimes they're just not nice numbers, but Sometimes if it's unfactorable, it'll end up in that category. If it's factorable, then it'll have 2 zeros or 1 0. All right, so here are some steps for using the calculator to help you find zeros, roots, solutions, x-intercepts. And so if you have them in your notes, you can go back and refer to them. If you don't have notes, you might want to copy these down. But these allow you to use the calculator to help you figure out where those solutions are. We're going to look at that in a second. But here is a picture of kind of the steps of what's going on in the calculator. All right, so what we're going to do is we are going to look at using the calculator to help us out, at least at the beginning. And then this is just something that you can play around with and get used to, and it'll be that tool that you can use when it comes to test time or anything like that. So what we're going to do is we're going to pull up our calculator. We're going to do number 1 and 2 with the calculator, and then I'm going to show you that it's not necessarily necessary. But we're going to go to y equals, and we're going to graph x squared minus 3x minus 10. Okay, graph. Now you may be able to tell where it looks like it crosses. The left 0 looks like it's crossing at -2. And then the right 0 looks like it's crossing about 5. Sometimes it's easy to tell, sometimes it's harder. But let's look at using those steps in the graphing calculator to help it kind of spit things out for you. So what we're going to do is we're going to hit the blue button and we're going to hit trace. And we want the 0, so we want the second selection. And we're going to have to choose, it doesn't matter which one we choose first. I'm going to do the left 0. So you get asked these questions by the calculator. If you notice down here it says left bound. And so what that means is it wants you to go and create like a leftmost point for the graph to be looking at. The graphing calculator can only look at one thing at a time. So what I'm doing is I'm coming over here and I'm creating like a left bound. And then in a minute, I'm going to create a right bound. And it's almost like I'm capturing that 0 in between 2 vertical lines. And then I'm telling the graphing calculator, tell me where the 0 is between here and here. So what I'm going to do is I've been left past my point of intersection, my x-intercept. I'm going to hit enter. And then now I need a right bound, so I'm going to hit right until I'm on the other side of that x-intercept, and I'm going to hit enter. And then the calculator is like, is it okay if I can guess? And I'm like, sure, calculator, go ahead and guess. So we're going to hit enter one more time, and there it tells you that the 0 is at -2, 0, or -2. And we have 2 intercepts. So I'm going to list them with a comma, but this is not a point in and of itself. So I'm not going to wrap it in parentheses. So I'm just listing out the zeros. If you wanted to write -2 and, maybe I'll do that instead. And now let's go find our other one. You could do that as well. All right, so now I'm going to do second trace. I need 0. And then I need to be left of this right point, rightmost 0. So I'm going to hit right. Okay, so right about here, there's my intercept. But I'm going to go left a little bit and hit enter to create my left bound. And then right a little bit to create my right bound. And then hit enter. Now, if you get those backwards and you're like, it says left bound and you're to the right, and then, you know, right bound and you're to the left, the calculator is going to freak out on you. And so it tells us it's here at 5. So we were able to see it. Now sometimes it's going to be a decimal. Sometimes it's going to be a fraction. It's not going to be pretty all the time. In this case it is, and so it was a little bit easier to read. You can also go to the table, and if you look at 2, you see that the y value is 0, and also if you look at 5, the y value is 0. So you have several things that you can look at using. But that's using the calculator to calculate the intercepts. But let's look at the fact that you don't have to use the calculator. So let's think about two numbers that we can multiply to get -10 and add to get -3. And those two numbers would be -5 and +2. So that would be x minus 5 and x plus 2. Now you can set each parenthesis equal to 0, x minus 5 equals 0, x plus 2 equals 0, and then solve for x in each problem. But you should also be able to see that we've got -2, like we did here, and we got 5, like we did here. So it's another tool in your toolbox. You learned how to factor, and then all we're doing with the factors is we're setting them equal to 0 and solving for x. Two little equations, two little one-steps right now. And then the other part is looking at the graph, whereas the x-intercept, that's also the answer. Now let me show you what's kind of going on here. Remember that we're trying to solve equations. Okay, so we're looking at solutions. So let's look at going back to, we're just going to go back here. And we're going to plug in each of these numbers. So I'm going to plug in -2. We're going to try this out. And this is kind of how you can check a little bit too and make sure that you have the right answer. So if this is truly a 0, I should be able to plug this answer, -2, in for x and get 0 when I hit enter. I do. And I should be able to also do it with 5. -3 times 5 minus 10. And so when I hit enter, I also get 0. So I'm plugging in these values that give me 0. And so it always comes back to 0, the zero product property helping us out to solve these. So we're going to go to y equals. We're going to clear out whatever we have. We're going to type in x squared minus x minus 6. And then we're going to look at the graph. And you may be able to tell what those values are. But I want you to practice the trace feature. So I'm going to hit second trace. I want the 0. I'm going to do, I always do my left one first. So you go left past my point of my x-intercept, hit enter. Go right past my x-intercept, hit enter. Hit enter one more time, and I got -2. And then I also have second trace 2, and I want to be left of my point, which I am, and I want to go right past my, and there I have 3. So -2 and 3. All right, let's try factoring it. Let's find two numbers that multiply to give us -6 and add to give us -1. They are -3 and +2. So that would mean I'm dealing with x minus 3 and x plus 2. And if I wanted to find these zeros, I would set x minus 3 equal to 0, and x plus 2 equal to 0, and then I would solve for x. Or I can think about opposite of -3, +3, opposite of +2, negative. Now, if you're going to be using the calculator to help you out, especially if the directions say factor or use a specific way to do this, it's not going to be good. But if it kind of leaves it open-ended, you can write that you used the graphing calculator to help you. And if kind of you need to explain yourself, where's your work kind of thing, you can write that I use the graphing calculator to help me find the zeros. But if it says factor and you chose to use your graphing calculator, that's not going to be correct. I want to see the factoring. But it is a way to help you check. So it is a good tool to have with you. So we're just going to keep on factoring, and we're going to try this out. And then, you can try it with the calculator to check and see if you did it right, those kind of things. So we are going to factor. So we're going to look for two numbers that multiply to give us -4. And I keep drawing these blanks, but remember that you don't have to do those blanks anymore. It's just a way for me to be able to show what we're doing. If you are beyond that, then that's great. So two numbers that multiply give us -4, add to give us 3 are going to be 4 and -1. So that means that I have x plus 4 and x minus 1. Now let's move into the, if you want to be setting these equal to 0, go ahead. But we should be able to catch on that we aren't necessarily needing that. We can look at doing a little bit of a shortcut. Okay, so if I plugged in -4 for x in my original equation, I should be able to get 0. And if I plug in 1 for my original equation, I should be able to get 0. If I graph x squared plus 3x minus 4 and look at where it crosses the x-axis, it should cross at -4. It should cross at +1. All right, let's look at number 4. Let's factor. Let's find two numbers that multiply to give us 25 and add to give us -10. So those numbers are going to be -5 and -5. And notice that they're the same number. So you could write this as x minus 5, x minus 5, but I would prefer to see x minus 5 squared. And so because of that, my parentheses match. I have two zeros that happen to match. There's really going to be one answer, one single solution. It's going to look like it's sitting right on top of the x-axis. And so the question is, where does it sit? And it's going to be sitting at 5. So there's 1, 0, 1 x-intercept at 5. All right. Now, the slide and divide stuff will also work. So let's look at factoring 4x squared plus 5x minus 6. So we're going to take the 4. First of all, there's no greatest common factor. And we're going to slide it down to the end. And we're going to have x squared plus 5x minus 24. I told you it wasn't going away. Two numbers that multiply give you -24 and add to give you 5 are 8 and -3. And so I'm going to have x plus 8, x minus 3. But I did slide, now I have to divide. I'm going to have x plus 2, and then I'm going to have this 4x minus 3. So that is what it factors to. X plus 2, 4x minus 3. Now one of them, not always, but one of them is usually easier to be able to tell just by looking at it. And this one, you can figure out the 0 pretty easy. -2, right? Because that's the opposite of +2. The other one, if it's hard to figure out just by looking at it, you can set it equal to 0. And this becomes a two-step equation. X equals 3/4. So this one might be one where it wasn't easy to tell on the graphing calculator. The graphing calculator intercept may have been more helpful. But if you have a fraction or decimal or something like that, it's because you have this slide and divide component. So slide and divide isn't going away. All right, let's look at number 6. So we're going to slide that 3 to the end. So it looks like I have x squared plus 4x minus 45. I'm going to find two numbers that multiply, give me -45, and add to give me 4. And I think that's going to be 9 and -5. And so then I'm going to have x plus 9, x minus 5. And then I'm going to, remember I have to slide and divide by 3. So I'm going to have x plus 3, 3x minus 5. And so this one right here is going to be opposite of plus 3, negative 3. The other one is a little bit tougher, but I would add 5, and I would divide by 3, I would get 5/3. Okay, we're going to graph a quadratic in factored form. So we have this set up. Y equals A is going to represent some number times x minus p. P is going to represent a number times x minus q. Q is going to represent another number. So A is going to have two jobs. Remember, it's either a reflection or a flip over the x-axis. And then it has a second job of being a vertical stretch or a compression. We'll talk about those in a little bit. We also have each parenthesis representing a 0. So x equals p would be one of the zeros, and x equals q would be another one. Remember, this is about opposites. So if I have a quadratic in factored form, I can get 2 points on my quadratic when I go to graph it right away, right from the equation. Now, when we are looking at the steps to do this, we are going to first identify the zeros. So that is going to be your first step. Figure out where the zeros are, plot them on the x-axis. You're going to look at the a value. If it's positive, the quadratic opens up. If it's negative, the quadratic opens down. Remember, a controls how it opens. Plug in the domain values between the two zeros, solving for y, and plot those points. Graph 2, I usually pick 2 points beyond the zeros if possible. So what I usually like to recommend doing is plotting 5 points minimum on your graph. And we will talk about some special points in just a second. But graphing at least 5, if you go over 5, the better your graph is going to look. Okay, provided that you're plotting the right point. If it's not looking U-shaped, you might want to investigate it a little bit further. All right, you are going to graph all of these precisely. No drawing, getting the zeros on there, and then just making a U wildly through them. You are going to graph precisely. So that means we're picking x values, we're getting y values. Now I'm going to show you a trick for that. All right, so the very first thing we're going to do, we're going to look at number 1. We're going to figure out the zeros. And so you just set each parenthesis equal to 0. So x plus 2 equals 0, what does x equal? Negative 2. And if x plus 6 equals 0, what does x equal? X equals negative 6. So those are our zeros. And so we're going to have a point at negative 2, 0, and a point at negative 6, 0. Our a value is in the front, like what's right in front of that first parenthesis, there's a 1 there. And so because that 1 is positive, it's going to open up and look like a smiley face. So that means that inside, it's like almost like right here and right here, I have my zeros. So inside those 2 points, somewhere down here, we have a vertex. So we have that place where it turns around and it starts making that going from decreasing to an increasing function. And so that is going to happen right at the midpoint. So if I look between negative 2 and negative 6, right in the middle is negative 4. So what I want to do is I want to figure out what's going on when the x value is negative 4. That will tell me where my vertex is. So I'm going to plug this in. I'm going to have negative 4 plus 2, and then negative 4 plus 6. I'm going to plug in negative 4 and see what I get. Negative 4 plus 2 is negative 2 times negative 4 plus 6 is 2. 2 times negative 2 is negative 4. So at negative 4, I have a y value of negative 4. So you can plug in negative 3. You could plug in negative 5. Those are other points that you could plug in. But I also want you to plug in points outside. So I would plug in negative 1. So I'm going to erase this And I'm just going to plug in -1 in for my parentheses. -1 plus 2, -1 plus 6. -1 plus 2 is 1 times -1 plus 6 is 5. 1 times 5 is 5. So -1, 5 is a point. Now the nice thing about this is that there is symmetry. We have all kinds of symmetry for our parabolas. So if you notice, from this blue point, I'm going up 5, right 1. I can do the same from this other blue point right here and go up 5, left 1. I have this symmetry. And then once I have 5 points, then I can try to connect them. Hard time. Right, there we go. Trying to get them connected. So there is my parabola, my quadratic. And it's got the x-intercepts right where I can see them, at -2 and -6. So you can go in the calculator and you can just plug in, even in the parentheses, x plus 2, x plus 6. And let's say you want the calculator to help you out. I mean, you can look at the graph. You can see that our graph's looking pretty good. And then you can even go to the table. And the table is where it's at. So if we're looking at -1, notice -1, 5. That was what we found. If you wanted to get -2, -3, -3. Actually, that looks like it's a point on our graph. There's -4 and -4. So you can get those points from the graph. But you have to remember that that's an option for you. Let's look at another one. So let's look at number 2. So let's figure out where our zeros are. So if I have x plus 2, the 0 is at -2. And if I have x minus 1, the 0 is at 1. So I'm going to go to -2, put a point, go to 1, put a point. Now if you notice, there is kind of this halfway, there's an odd number. Over here on the left, there was an even number of units between my two zeros. So when there's an odd number, that means our vertex is going to be at a fraction. All right, our A value, we look right in front of our parentheses, and we see a -1. That means it opens down. So that means that this is going to look like, it's going to flip upside down. It's going to be a frowny face. Now, because our vertex is a fraction, we might want to pick some numbers that maybe are nice. So look here, 0, when x value of 0 is in between those 2 points. So let's plug in 0. 0 plus 2, 0 minus 1. 0 plus 2 is 2. 0 minus 1 is -1. So we have a negative times 2, that's a -2. -2 times 1 is +2. So I plugged in a 0, I got a 2. Okay, so from this red point, I can go down to right 1, or I can go from the blue point right here, go up to left 1. So I can do the same thing from my blue point on the right. I can go up to red 1, so I can put here. So if you want to double check that, we can plug in -1. We should also get 2. So -1 plus 2 is 1. And then -1 minus 1 is -2. So we end up with a -1 times a -2, which is a +2. So that means the vertex is going to happen somewhere in here. We're not 100% sure where. Let's say we want the graphing calculator to help us. It's probably halfway between 0 and -1. What's halfway between 0 and -1? -1/2. So let's try putting that in the calculator. We're going to get out of here. We're going to plug in negative. And we're going to have -0.5 minus plus 2, and then negative 0.5 minus 1. All we're doing is plugging in x values, getting y values. Oh, and I get 2¼ So 2¼ is just a smidge above 2. Green arrow right there. Here's that. Here's this. Now we're just going to be a smidge right above, like right in there. Okay, let's get 2 points on the outside. So we're going to plug in, I'm going to plug in 2. So negative 2 plus 2, 2 minus 1. So negative 4 times 1 is going to be negative 4. So 2, negative 4, and this thing has all kinds of symmetry. So from this right blue point right here, I went down 4, right 1, so I can do that on the other side. I can mirror image it. Down 4, left 1. And then look, I've got lots of points, and I just connect them. And then I've got a beautiful, beautiful, maybe beautiful Alright, so let's find the zeros in this one. So it looks like we have an x value of negative 5 and negative 3. So here's negative 5, here's negative 3, and that means I'm going to probably have my vertex at negative 4 in between those two. Alright, my a value, what's in front of my parentheses? 2. It's positive, so it opens up. And because that 2 is there, we're going to talk about this more later this week, it's stretched. So it's going to look taller and skinnier than the past 2 functions that we've graphed. Alright, so what we're going to do, I'm going to plug in negative 4. Negative 4 is going to give me my vertex. So 2 times negative 4 plus 5, negative 4 plus 3. So 2 times 1, negative 4 plus 3 is negative 1. So 2 times 1 is 2. 2 times negative 1 is negative 2. All right. We need a couple of points on the outside. We're not going to go crazy. We're just going to stick right close by. So I'm going to plug in negative 2, and then we're going to use the other, use what we get for that answer to help us out with 6. Because whatever we're doing on either side of the parabola is going to be the same. So let's plug in negative 2. So 2 times negative 2 plus 5, negative 2 plus 3. So 2 times 3, negative 2 plus 3 is 1. So 2 times 3 is 6, 6 times 1 is 6, so negative 2, 6, right there. And then because negative 2, 6 is on one side, negative 6, 6 is on the other. And that's symmetry with the stuff. Alright, so we've got 5 points. We're going to connect them and get a nice parabola. And it's okay if it doesn't hit exactly, but I want to see those points. So if you don't have points or your points are not able to be seen, you might want to fix that because I want to see what you're actually graphing. All right, why don't you try number 4? See if you can figure out any of this stuff. Pause the video. All right, 1, 0, x minus 3, 3, x minus 1, 1. Has an a value of negative 2. That means it opens down, and it's going to be stretched. All right, so let's plot 3. Let's plot 1. That means that 2 is going to be where my vertex is because it's directly in between my 2 x-intercepts. So I'm going to plug in 2 and see what I get for a y value. So negative 2 times 2 minus 3 times 2 minus 1. So all I'm doing is plugging in 2. Negative 2 times negative 1 times 1. Negative 2 times negative 1 is 2. 2 times 1 is 2. So let's make this red. 2, 2 is a point. Now, I want to see at least 5. I only have 3, and I have space to give 5. So I'm going to keep going. I'm going to pick something on the outside, like 4 or 0. Ooh, I like 0. Let's plug in 0. So negative 2 times 0 minus 3, 0 minus 1. All right, so negative 2 times negative 3 times negative 1. So negative 2 times negative 3 is 6. 6 times negative 1 is negative 6. So 0, negative 6. That would mean that 4 would also be negative 6. So there I have my 5 points. Let's connect them and make our parabola. There he is. Great. I think we have a couple more problems and then we'll be done. All right, so let's look at 5. Zeros. Can you tell what they are? They're negative 4 and positive 2. So let's get them on the graph. Negative 4, positive 2. So they are an even distance apart. We will find the vertex. But maybe because, do you see how wide they are? We might want more than just the vertex in between. So we'll play around with that in a second. A is 1/2. It's positive, so that means it opens up. And it's going to be wide. This is actually a vertical compression. So we will have a wider parabola than our normal parabola. So let's plug in some numbers. So let's see, halfway point, they're 1, 2, 3, 4, 5, 6 apart. So half of 6 is 3. So 1, 2, 3. So it looks like about -1 would be where our vertex would be located. So we're going to plug in -1. We're going to see what we get. All right, half of -1 plus 4 times -1 minus 2. It's going to be 1/2 of 3 times -3. All right, 3 times -3 is -9. -9 times 1/2 is -4.5. -9/2. So we're going to have to estimate a little bit. So at -1, we're going to go down 4.5-ish, right about there. And I'm going to pick a couple other points. So like probably going to do 0. 0 would be a good point. Let's try that. 0. 1/2 of 0 plus 4 is 4. 0 minus 2 is -2. So half of 4 is 2. 2 times -2 is -4. So right here. Right here. And then let's pick a point outside this. Now, because of this 1/2, I'm thinking that maybe an even number would be better to choose. So let's try 4. Now, if it's too big, we don't have to graph it, but 4 plus 4, 4 minus 2. Okay, so 1/2 of 8 times 2. So 8 times 2 is 16. Half of 16 is 8. So 4, 8. That'll fit. I just need to get rid of my work. So 4, 8. So from this red point here, I went up 1, 2, 3, 4, 5, 6, 7, 8, right 2. So I'm going to do the same thing, but I'm going to go to the left. So up 8, left 2. So remember, the more points you have, the better your picture is going to look. All right, let's look at number 6. So number 6, our x values, our zeros are 3 and -3. So 1 up, -3, 1 up, +3. Our a value is -1. That means it opens down. Looks like some numbers in between are going to be 0. That's going to be a good one. So -0 minus 3, 0 plus 3. So -3 times 3. -3 times 3 is -9, and -9 is a +9. So all the way up here. Actually, I might want to get rid of that. Right there. All right, so that's a pretty big jump. So maybe we want to get some other points, and maybe like 1. negative 1 minus 3, and 1 plus 3. So negative, negative 2 times 4. So negative, negative 2 is a positive 2. 2 times 4 is 8. So we're at 1, 8. And we can use that mirror image, that symmetry, line symmetry. Let's say we want to get 2 in there. Why not? Let's try it. So negative 2 minus 3, 2 plus 3, negative, negative 1 times 5. Negative times a negative is positive. So 2, 5. And then we also have negative 2, 5. Let's try getting 1 on the outside. Let's try 4. Let's see what we can do. So negative 4 minus 3, 4 plus 3. So negative 1 times 7 is negative 7. So 4, negative 7. But that's about all that we're going to be able to fit on there, other than the one on the other side, right there. Okay, so we have this nice big parabola with lots of points. Okay, on Friday, you're going to have a graphing quiz with all the different types of quadratics, the way that they're written, and one of them is going to be the factored form of the quadratic. So make sure you are practicing how to handle that. You can use your graphing calculator on the quiz. So if you want to practice using the graphing calculator, I would recommend doing so on the homework. All right, that's it for this lesson. Bye.